The index of refraction is temperature dependent. Mirages are created by the difference in the index of refraction of the hot air that's close to the ground and the cooler air that's above it. Light bends along the ground, which makes it look like the light is being reflected from a puddle to the motorist. I'm sure you've all seen this effect. Dispersion occurs when light is separated into its different wavelengths. The image here on the right shows white light entering the prism and then being separated into the colors of the rainbow. Dispersion occurs because incoming light of different wavelengths is bent at different angles as it moves into a refracting material. Remember, light is going to slow down as it moves into a material that is not air or vacuum. The different colors of light have different indices of refraction. Violet has the highest N, red has the lowest N. What that means is that violet light is going to bend more than red light. It also means that red light is going to travel faster through violet light in water drops in a prism. And you can think about it this way. Red light's traveling faster, has less time to bend. That's something that might help you remember which bends the most and which bends the least. In order for us to see a rainbow, the sun has to be shining from behind you, and the raindrops have to be in front of you. So the next time you see a rainbow, pay attention to that. The radius of the arc of the rainbow is 42 degrees. The light is going to enter the raindrop and refract as it's entering, reflect off the back, and then refract again as it leaves the raindrop. And then we're going to perceive it or see the different colors of the rainbow. A double rainbow happens when light rays are reflected twice inside the raindrop. And in the second rainbow, the colors will be in the reverse order. It's possible to see a circular rainbow. You have to be above the storm. The sun has to be behind you, and the raindrops have to be down where you're looking. A diffraction grating is a device that's composed of many equally spaced, very, very small parallel slits. Light is diffracted, and the result is that the light is going to be separated into the different colors of the rainbow. Definition of diffraction is that waves spread or bend around the edge of a barrier. Here on the left, you see a single barrier. As the light passes through the barrier, it will form a circular pattern. If two slits are present close to each other, then the light will pass through and will form this circular pattern again. Think about a drop in a pond. It makes this sort of a pattern. Light's going to do the same thing through a small slit. Then we're going to see areas of interference, constructive and destructive, where you'll have bright areas of lightness and darkness in the interference. This slide shows the equation needed to calculate the wavelength for light that's being shown through a diffraction grating. And we'll do this lab in class. A laser is a device that produces coherent light at a single wavelength that is in phase. And lasers are useful to measure very, very large distances. The laser pointer most teachers have is one single wavelength of red light.